acing your technical coding interview questions. Today we shall be looking at this question that says k closest point to origin. And the question says that given an array of points where point I equals to xi, yi represent a point on the xy plane and an integer k, return the k closest point to the origin. So to estimate that closeness, they're saying the distance between the 2 points on the xy plane is the Euclidean distance, and that is represented by this. So you may return the answer in any order, and the answer is going to be unique except for the order that is in. So this is an example. We have this point and we have to estimate the distance from here, and we have to return the closest, which is this. Okay, so the distance between 1 and the origin is square root of 10. This time is square root of 8, so this is smaller, so that is closer, and k is 1, so we take that. So here we have this. The point length could be up to 10 raised to the power 4, and the values in it could be negative or positive. I think this is pretty straightforward. So what we need to do is to have a function that will give us this. Given a point, we know we're calculating the distance from the origin, so we can fix this in our function and we can estimate that. So let's deal with that first. So let's have a function that calculates the Euclidean distance, a function that returns, let's say, calculate the Euclidean distance. Okay, so we call that function and we say it is Euclidean distance. That's a good name for it, Euclidean distance. And that function is going to take a point, and what it will do is going to return to us the equation that we have been given here, this equation. So I'm not going to use the square root because it really does not matter, because we want to compare the values. So we can just say that point that will be entered is going to be a tuple. So we take the first part of it, which is point 0. We deduct it from 0 and we raise that to power 2. Then we take the other point 1, we deduct it from 0 and we raise that to power 2. So that should give us the Euclidean distance. Now the next thing for us is to now go through each of the points and estimate the distance using the Euclidean distance. So we go to each of the points here. Now for us to do that, we will go to for points, for point, in point, and we go through this. Now we need to implement this walkthrough. So we're going to take each of these points and send it to this Euclidean distance, and it's going to return to us the distance between each of the points. So we need to have a variable that will keep track of that particular value. So let's have a variable for, let's call it the distance, or distances. Okay, so it's going to be a list. Now a list is going to work here because we are going to return at the end of the day the point, so we need that list to be a list of tuples, so that we put in the point and as well as the distance in a tuple. we could have used a dictionary like I did before, but some of the test cases will not pass because we could have duplicated Euclidean distance, and that's going to be replacing the existing one, if you get what I mean. So we're going to use this list, and the list will be a list of tuples. So we send the point into what we call the Euclidean function that we define, and we send the point to that to get the value. We're going to append that to the distance list. So distances dot append. So we're going to append that result to that. But in addition to that, we also want to keep track of the point. We need this point. So we're going to actually append a tuple in that. So we need the point. So we're going to append the point as a tuple with the Euclidean distance. So when we do a walkthrough, you'll see what I mean. And that's done. So the next thing we just need to do is to sort our distances. So we use a sorted function to sort the distances, and we know the distances has to be sorted by the Euclidean distance, so by the first element. So that means we're going to use a key which is equals to lambda and takes in a x, and each of the x is going to be sorted by the first value there, and automatically it sorts this in ascending order. So we're going to put our sorted distance in. So distance is sorted in a new array. Alright, so we're almost done. What we just need to do now is just to go through this distances sorted and just return. We just need to return the first k point. So to do that, we might want to declare our result array so that we just add that to it, and we only need the first k, so we don't need to go through everything. So we can either use a variable and say I equals to 0, and we say y I is less than k because that's what we want. We continue to add to our result. So result dot append, and that will be our distances underscore result underscore sorted, and we just take the second element. So we take the without work because we need to iterate through this as well. Okay, so this will not, we need to go through this. So we can say for distance in the distance sorted, so this will give us each of the value. And what we just do is we just append the second element, so the dist of 1, because this is a tuple. This guy is a tuple. So the first element is the distance, the second is the point. So this is the second. So we just append that. And what we do is we check if, just to do some housekeeping there, if we don't really need this, we can just return the first k. If you want to do it this way, we can just return result of k. So in that wise, we don't need this, or we may decide to use it early on and check if the length in result, if it's equals to k, we can just return it. So here we can look here and say if the length of the element in result, if it's already equals to the k, so we can just return result. In that way, you might not even need to get here at all, whichever way, still okay. And that's it. So let's just quickly go through and see what we have done using an example. We still have time. So what will happen here is that an Euclidean distance is going to be calculated here by the time, okay, this is empty, so we take point. So we're going to take this pause as a point, which is 1, 3, and we're going to send this 1, 3 as here. So it's going to call Euclidean distance with 1, 3, and this is going to give us a value, and that value will now be stored in the distance, whatever it gives us. Okay, so I assume that will be 1 square plus 3 square, that will be 10. So this is going to give us a list that has a tuple. The first value is 10, the second value is a tuple. Is it a tuple? What did they use? Okay, they use a list. It's a list, so that's going to have 1, 3 this way. So by the time we go through the second one, minus 2, that is going to be 4 plus 4, that will be 8. So this will give us the second value will be, this is a tuple, so this one is going to give us another tuple. This will be 8, and it's going to be negative 2, 2. Okay, so by the time we sort this is going to come back to this when this is sorted. So we're going to have this, our sorted distance, to give us this array, which, because we are sorting with the first element, so 8 and 10, so 8 comes first, and the second element will be included here. Okay, so the next is just iterate through, we go through each of them, we append the second one, so this will be appended to this. So here we're going to have this as negative 2 and 2, then the length is 1. What is k? K is 1, so this will return the result. Yes. Okay, because of our time, I'll not walk through the rest. I'll just run that, and let's see the second one. We have an error there, so we should have a column so that we don't have issues. Sorry, okay, that should work. So the second one, just run that. Okay, is 2. So our time is almost up, so we run this. Okay, so what is the space and time complexity? So it's going to be linear, so I submit that. Well, because of this sorted, if we don't consider this sorted, but it's going to be linear, and the space is also going to be linear. Alright, okay, thank you, and see you in the next one.